Hello class, and welcome to today's algebra lesson, which is about solving quadratics by completing the square. By the end of the lesson, you will be able to complete the square and then use that method to solve quadratic equations. So what does it mean when we say completing the square? The goal of completing the square is to get back to a perfect square trinomial. The perfect square trinomial was one of our special cases. So we were able to take the square root of the front and the square root of the back, and then notice that multiplying those, so x times 5, gave us half of our middle. So when we complete the square, we have a factor of x plus 5 squared. It's the same thing twice. So when you are completing the square, we are trying to construct that perfect square trinomial. So we're going to take half of the b value. So in this case, notice our b value was 10. Half of that was 5. And then we square that. 5 squared gave us the 25. So we are using that to complete a trinomial to a perfect square. So we've got a couple of different examples of this process here. This first one, I've got a is 1 and b is 6, and we are trying to find that c value. So the first step is to take the b value and cut it in half. So half of 6 is going to give you 3. Then you are going to square that, which is going to give you 9, and that is your c value. So your perfect square trinomial here would be x squared plus 6x plus 9. So our complete trinomial is x squared plus 6x plus 9. Now coming down here to our second example, I've got a is equal to 1 and b is equal to negative 11. C is once again what we're trying to find out. When I go to cut negative 11 in half, that would give me a decimal. So instead of turning it into a decimal, I'm going to leave it in its fraction form, which is negative 11 over 2. Then when I square that, that means I'm squaring the top, which is 121, and squaring the bottom, which is 4. So my perfect square trinomial then becomes x squared minus 11x plus the fraction of 121 over 4. So if it is not going to divide out to a whole number, like 6 divided by 2 gave us 3, if it does not divide out to a whole number, you are going to end up with a fraction as part of your answer. Go ahead and try this one on your own, writing the perfect square trinomial as your final answer. So we half 8 because our b value is negative 8. Half of that is negative 4. Squaring that gives us 16. So our perfect square trinomial is x squared minus 8x plus 16. So how does that help us actually solve? The first part is to make sure that we have x squared and bx on one side. Notice, this is only being applied if it is an x squared. If it is not plain x squared, we will go over a couple examples of how to fix that in a moment. Then we're going to do the complete the square process and add that c value to both sides of the equation. It is critical that you add it to both sides. You're going to simplify it down to its factor, use our square root property, and then solve for your values of x. So right now we've got x squared plus 12x is equal to 0. We've got a regular x squared paired with the x and no other numbers, so I can now begin my process. I'm going to take my b value, which is 12, and cut it in half to get 6, and then square that to find that my c value is 36. So I add that to both sides, so x squared plus 12x plus 36, and then is equal to 0 plus 36 on my other side, adding it to both sides of the equation. Now I need to do my factoring and my simplifying. The factor side is easy. We know that it's a perfect square trinomial, So it's going to be x plus that half value squared. And then the other side, I've got 0 plus 36 is 36. Now I can apply that principle of square roots from our last lesson and take the square root of both sides. So my first piece is x plus 6. The first square root of 36 is the positive version, so 6. My second square root of 36 is the negative version, which is negative 6. Now I have two equations that I can go ahead and solve. And I've got x is equal to 0 and x is equal to negative 12. Once again, these solutions tell us where our quadratic function is crossing the x-axis. We're looking for the same thing we've been looking for the last couple of lessons. We're just doing it with a different method now. You can double check your answers by plugging it back in. You could do 0 squared plus 12 times 0. 0 plus 0 does in fact give you 0. Or you can plug in negative 12 squared, which is a positive 144, plus 12 times negative 12, which is negative 144. 144 minus 144 is in fact 0. Once again, you do not have to check your answers, but just know that it is possible. Go ahead and try this one on your own. So we take half of b, square that to get 9. We add 9 to both sides. So I've got x squared plus 6x plus 9 is equal to 0 plus 9. Square rooting both sides, I end up with x plus 3 equals 3 and or negative 3. Solving, I get answers of 0 and negative 6. Sometimes the x and the x squared are not going to be isolated. So we have this extra plus 3. If you have a number being added or subtracted with your variables, that first step is to isolate the variables. So I'm going to go ahead and subtract 3 to get rid of adding 3, meaning that I've got x squared minus 14x is equal to 5. Now that x squared and x are by themselves, I can go ahead and start that completing the square. So I take half of my v value, which is negative 7, square that, which is 49. So I add 49 to both sides of the equation. X squared minus 14x plus 49 is equal to 5 plus 49. Then I go ahead and do my simplify and factor step. So on the left side, I've got my perfect square. In this case, it's subtracting because I have a negative 14 in the middle. And then I've got 5 plus 49, which is going to give me an answer of 54. I can now apply my principles of square roots and square root both sides of the problem. So I get x minus 7, the square root of 49, or excuse me, not 49, the square root of 54 is a long repeating decimal or non-repeating decimal, which starts with 7.348. That's going to round us to 7.35. We always want to go to those two decimal places. Then the other case is x minus 7 is equal to negative 0.35. To solve the equations, I'm going to go ahead and add 7 on both sides because that is how we get rid of subtracting 7. So my first answer to this problem is going to be approximately 14.35 after our rounding. And then when I solve my second answer by adding 7 on both sides, I get x is equal to about negative 0.35 with my rounding. So we still have our two answers, one from the positive case and one from the negative case. You can plug them back in to verify that it would in fact equal 0. Go ahead and try this one on your own. Starting by subtracting 12 on both sides to isolate our variables. Cutting 6 in half is negative 3, squaring that is 9. Adding 9 to both sides, we end up with x squared minus 6x is equal to, or plus 6x minus 6x plus 9 is equal to 16. Square rooting both sides, solving for both of our answers, we get 7 and -1. So for this next example, the first thing that we need to do, once again, is get our variables by itself. So I'm going to go ahead and subtract 25 from both sides of my problem. So I have 0.1x squared plus 2.4x is equal to 405. Now, this one is different because I have a number in front of x squared. In order to complete the square, that value, that a value, is not allowed to be there. So you need to divide everything by the a value. So if there is an a value in front other than 1, your second simplifying step to set up your process is going to be to divide by the a value. 0.1 divided by 0.1 gives us just x squared. 2.4 divided by 0.1 is going to give us plus 24x. And 405 divided by 0.1 is going to give me 4,050. Now I have an x squared by itself and x squared and x on the same side, so I can complete my square. Half of 24 is 12, squaring that is 144. So I'm going to add 144 to both sides of my equation, resulting in this version of my equation. Now when I simplify and factor, my left side becomes my perfect square format. So I've got x plus 12 squared. And then when I do my addition on the other side, I get 4,194. I am now at the point where I am able to square root both sides of my equation. And when I do that, I am going to get x plus 12. And then once again, we're going to need to round. So I've got 64.761, which is just going to round to 64.76. And then we have our negative case as well, because square roots can be both positive and negative. Then I'm going to do my final step of actually solving the problem and subtract 12 on both sides. So my first answer is going to be 52.76. And when I solve the second one, once again, by subtracting 12, I get my second answer of -76.76. So we have our two answers by completing the square. Again, first step is still to subtract. Because there was an a value, you also have a division step before you can complete the square. Go ahead and try this one on your own. So once again, your first step, adding that 12 to both sides. We had an a value, so I divided everything by that a value, giving me x squared plus 2x is equal to 4. Halving my b value, I get 1. Squaring that, I also get 1. So adding 1 to both sides, I get x squared plus 2x plus 1 is equal to 5. Simplifying and square rooting, and then solving, I get x is equal to 1.24, or x is equal to -3.24. So for this final example here, I'm going to start by adding 18 to both sides of the equation. And I end up with -2x squared plus 8x is equal to +24. Then I am going to go ahead and divide all pieces of my equation by a -2 so that I have just x squared in the front minus 4x is equal to -12. Then I'm going to pull out my b value and cut that in half. So -2 squared is +4. I end up with x squared minus 4x plus 4 is equal to -12 plus 4. Then I am going to go ahead and factor and simplify. So I've got x minus 2 squared is equal to negative 8. Now, when you go to square root this and you type square root of negative 8 into your calculator, you are going to get an error message. What that means is that we can no longer continue solving this problem, and we end up with a no solutions case. So when you end up with an error message on your square root, that is when you stop and you can conclude that there are no solutions. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.